day everyone, my name is Devi Depni Victor and I represent Group 2. Today, our team, including myself, Dosimon, Irfan, Shahira, Ashraf and Hazik, will be presenting our proposal addressing the aerotrain suspension issue. Greetings, today I am going to shed light on the recent suspension of aerotrain operations at KLIA main terminal by Malaysia Airports Holding Berhad. This decision, prompted by the recurrent breakdowns of the aging trains, brings to the forefront significant management challenges within the organization. While the immediate provision of shuttle bus services aims to prioritize passenger safety, it underscores a reactive rather than proactive approach to contingency planning. These situations underscores the urgent need for MAHP to address systemic issues in maintenance, communications, and customer service. By implementing robust maintenance protocols, fostering transparent communication, and enhancing customer service strategies, MAHP can fortify the reliability of airport operations and uphold its commitment to passenger satisfaction.
Good day, sir. I am Shahira Omar and will continue with our project planning presentation. According to the article, Malaysia Airport Holding Berhad stated that aerotrain services in KLIA should be suspended because there were technical problems occurring in the train operation system. Therefore, this project approached our team to analyze the train system including the mechanical and electrical failure that occurs through the operation. Then the train that have been repaired should have been tested before submission to observe any improvement in the train system process. In summary, the objectives of this project are to check and identify any technical problem that causes the disruption of the train operation. Secondly, to analyze and develop the equipment failures cost management plan. Then, by identifying any necessary solution to ensure the long-term reliability of the train operation, the provided protocols should have been used to implement the repairing procedures. And lastly, to ensure that train operations continue operate as soon as possible to minimize passenger inconvenience. Work breakdown structure (WBAs) in a project management is a hierarchical subdivision of a project into smaller parts that are easy to manage. There are four major parts of these WBAs, which are tasks, procurement, repair work, and testing. For tasks, project managers should have been conduct a detailed inspection of the current transportation and operation system to analyze the route that causes the technical problem, then develop a project plan for a strategic result. Then, the team should have been produced a detailed resources plan including the timeline and required equipment which is necessary for the repairment. It is important for the project manager to engage with contractors, suppliers, and employees by establishing a communication protocol such as regular meetings to keep them informed on the project progress. Next, the project manager should have been always monitoring the employees to avoid unpredictable problems during the repair work. The contractor should have been conduct the work by restoring the necessary electrical and mechanical system in the train operation system. Last but not least, before submission, it is important to perform the testing and experiment to ensure the reliability of the upgraded system. And the team should have been provide a final report and submit the finished project when there is no issue that occurs during the testing. In this case, the resources planning and establishing a project team are important in any project management. First of all, the human resource strategy of this project focuses on developing capable and motivated employees to ensure the successful completion of paperwork and the efficient restoration of the train operation system. This also involves defining specific roles, duties, and responsibilities for every related stakeholder. Furthermore, the Malaysia Airport Holding Berhad project requires technical instruments, repair equipment, replacement components, and training facilities. In this case, the diagnostic instruments such as voltage meters and thermal scanning cameras allow for an accurate assessment of the condition of the train system. Next, cost management is one of the main parts in providing the budget needed throughout the project process from the start until the end. This can be helped by requiring an accurate estimate of both direct and indirect costs, then developing a comprehensive and phased-in budget. Last but not least, stakeholder analysis for the project involves defining each of the major stakeholders, both internal and external, along with assessing their interests, expectations, and influence over the project. This approach includes gathering information from stakeholders through surveys or interviews by visualizing their connections to discover possible collaborations or conflicts by creating engagement and management strategy to successfully serve their requirements. In terms of the project team, they are given different responsibility to accomplish this project. The project manager is responsible for monitoring every phase throughout the project progress, including planning, execution, and implementation. The technical team, including specialists in engineering, design, development, and maintenance, contributes essential knowledge for this project. The safety team is important in securing the health and welfare of all project stakeholders via placing safety foremost throughout the project. This includes adhering to health and safety regulations, standards, and guidelines that conduct through risk assessment. Refer to the figure in the slide. This is our team organization chart for the Malaysia Airport Holding Berhad project. There is a project manager, engineering manager, stakeholder manager, construction manager, quality manager, and other functions that has their own roles, duties, and responsibility throughout the project progress.
Greetings to everyone. My name is Muhammad Ashraf Akmal and I am part of Group 2. I will be presenting for project scheduling. To ensure the timely and successful completion of this critical project, we need effective project scheduling. For this project, we will be using the critical path method or CPM. This method allows us to determine the prioritize the sequence of critical tasks that have an immediate impact on the project's completion schedule. Moving on into the next part, which is identify activities for network. Firstly, for assess current trend conditions, we will start by performing a complete inspection to identify any malfunctions or areas needing maintenance. Next, for the plan repairs and parts replacement, based on the assessment results, we will develop a detailed repair plan. This involves collaborating with technical experts to create a repair schedule, prioritizing critical repairs, and identifying task dependencies to optimize efficiency. Then we will source and acquire all essential tools, spare parts, and materials. Our procurement specialists will engage with vendors to obtain quotes, negotiate price, and place orders. Furthermore, for hire and train additional personnel, we will assess our staffing needs, recruit skilled personnel, and provide necessary training. Fifth, implement safety checks and testing. Safety is our top priority, so we will conduct comprehensive safety checks and testing of repair systems. And finally, we will perform detailed inspection to verify compliance with safety, quality, and performance standards. Now, let's discuss the assigned roles for our aerotrain recovery project. To ensure the project runs smoothly and efficiently, we have designated specific roles for key personnel. These roles include the project manager, technical lead, procurement specialist, HR manager, and safety officer. Each of these roles is crucial for coordinating activities, managing resources, and maintaining safety standards throughout the project lifecycle. Now, let's summarize our project schedule. The Gantt chart provides a detailed timeline for our project, divided into 4 key phases. Firstly, phase 1. This phase includes stakeholder identification, detailed project planning, and budget allocation and approval. The duration it takes is around 1 to 3 weeks. So next one is phase 2, where it runs around week 4 to week 10. This phase covers repair work planning, procurement of materials, initial repair works, and setting up testing and QA. Third one is phase 3, where it runs around week 11 to week 15. Activities in this phase include comprehensive safety inspection, trial run preparations, and safety for performance review. And lastly, phase 4, the finalization. It runs around week 16 to week 20. This final phase involves making final adjustment and repairs, conducting final quality control, performance monitoring, and project closure and documentation. Additionally, we computed slack time to identify the critical and non-critical paths within our project. Activities on the critical path have zero slack time, indicating they must be completed on schedule to avoid project delays. Non-critical path activities have some slack time, providing flexibility in their completion. By closely monitoring these schedules and slack times, we can ensure that the project progresses smoothly and efficiently. aiming for the timely and successful restoration of the aerotrain service. According to our CPM analysis, the total estimated duration for the project is approximately 22 weeks. This timeline is based on critical path identification and sequencing of key activities to ensure timely completion of the project. In terms of cost estimation, the total project cost is estimated at 493,300 ringgit. This includes costs associated with labor, materials, equipment, and overhead expenses required to execute the repair activities and restore the aerotrain operation. By understanding these estimated durations and costs, we can effectively plan and allocate resources to ensure the project stays on track and within budget. Moving on into the project controlling. Project controlling involves closely monitoring resources, costs, quality, and budgets to ensure that we stay on track throughout the project life cycle. For resource database, this database will serve as a centralized repository for detailed information on all project resources, including human resources and equipment. Also, we emphasize continuous improvement in our resource management approach, where it involves gathering feedback from stakeholders and the project team to assess the effectiveness of our procedures and tools. Second one is cost. This approach allows us to track labor, material, and equipment costs as they occur, providing a current summary through real-time dashboards. And also, this involves smartly distributing finances across various cost categories, including labor, materials, equipments, and overheads. Moving on into quality, we will define precise quality standards and performance requirements tailored to aerotrain repair. While for the continuous improvement initiatives, we will gather feedback regularly and analyze quality issues to identify areas for enhancement and make ongoing improvements to maximize aerotrain performance and customer satisfaction. Next is time. We will create a detailed work breakdown structure, WBS. So this structure will help us organize and sequence project activities into manageable tasks with specific responsibilities and deadlines. While for regular progress tracking, it allows us to evaluate progress, identify schedule changes, and take necessary actions to minimize risks and delays. Lastly, proposing on the feedback approach. So by gathering insights and feedback from stakeholders, we can make immediate adjustment to project schedules and resource allocation, promoting cooperative problem solving and enhancing stakeholder satisfaction. While the other hand, for the root cause analysis, we will implement proactive solutions to prevent recurring issues, improve project quality, and optimize resource utilization.
Assalamualaikum and good day. My name is Muhammad Irfan, BK2116032, a 30 student. I'm going to present about the quality management. So, what is quality management? It is crucial for business since this boosts competitiveness, saves costs, and enables agile responses to changes. There are three key perspectives on quality, which is meeting customer expectation, adhering to standards, and also emphasizing product features. Each perspective contributes to understanding what makes a product outstanding. Quality impacts various facets of a business, including reputation, product perception, employment, and supplier relationships. It is also vital for global competitiveness. What we must do next is to identify the problems. Smooth operation at aerotrain at Calais is vital. Frequent breakdowns, service interruptions, and passenger inconvenience are significant issues. There are steps to identify problems, which is to collect and analyze maintenance record and incident reports, gather the passenger feedback, and also to review the performance metrics. Key issues are technical problems, mechanical failures or software glitches. Second one, maintenance issues, poor or insufficient maintenance. The third one is operational inefficiencies, delays or operational errors. And the last one is staffing issues, lack of training or insufficient staff. And the purpose of analysis is to find root causes of problems and develop solutions to enhance aerotrain reliability. The outcome that we get from this is we get to improve the aerotrain reliability and also to improve the customer feedbacks and the comfortability. Next, an Ishikawa diagram known as fishbone is used to analyze the root cause. The first issue is aging infrastructure. The aerotrain system has been operating for 25 years, exceeding its expected lifespan. The frequent breakdown disrupts service, inconveniencing passengers and damaging the airport's reputation. The second issue is circuit breaker issues. Trip circuit breakers within the aerotrain system cause frequent breakdowns, and these breakdowns halt train operations suddenly, posing safety risks to passengers and disrupting airport operations. The third issue is technical failures. Even replacement trains deployed during breakdowns face technical difficulties. These technical failures prolong downtime and complicate repairs, worsening passenger inconvenience and operational challenges. And the last one is maintenance challenges. Aging technology makes it challenging to obtain replacement parts and conduct maintenance efficiently. Difficulty in sourcing parts prolongs repair times, leading to extended downtime and increased maintenance costs. Moving on to the quality management process flowchart for aerotrain repair project shows the step for ensuring the aerotrain works well at KLIA. First, there is an initial scheduled inspection to check for problems. Then, issues are identified and sorted for fixing. This leads to either initial troubleshooting or detailed diagnosis and repair procedures. After fixing, there is testing to make sure everything is okay, and the process repeats to gather feedback and make ongoing improvements. This shows how quality management keeps improving the aerotrain service for passengers at KLIA. Next is general inspection approach. This is the table prepared, and as you can see, the routine maintenance frequency is weekly, and the components that are checked are the train system, tracks, doors, signage, and also to check for wear damage, functioning, and to keep operations safe and intact. For the daily check, it is done daily, and the components checked are the brakes, emergency system, passenger areas to ensure safety and functionality and to essential for daily safety. The third one is preventive inspection. It is done monthly. The fourth one is quarterly review, which is frequently over 3 months, and the last one is annual audit, which is done yearly. Next, key benefits of quality improvement approach. The first one is enhanced reliability. There are fewer disruptions by fixing root causes of breakdowns. The second one is improved safety. Upgraded safety features protect passengers and staff. The third one is operational efficiency. Streamlined processes and updated technology reduce downtime. And the last one is better passenger experience. Reliable and safe service improve satisfaction. The implementation steps are to analyze breakdowns and technical issues, implement technology upgrades and better maintenance procedures. The last one is train staff and optimize the supply chain for spare parts. This continuous effort ensures the aerotrain service maintains high standards for quality, reliability, and safety for passengers at KLIA. Furthermore, total quality management TQM enhances organizational effectiveness by reducing error and focusing on customer satisfaction. The second one is involving employees and ensuring process adherence. Influenced by experts like Deming and Duran, TQM also aligns with organizational strategies for productivity and cost reduction, improve customer loyalty and satisfaction. And the next one is key step in TQM include defining quality and securing leadership commitment, focusing on customer needs and continuous improvement, and engaging employees for better outcomes. Next, TQM tools like Six Sigma and ISO 9000 support systematic problem solving and quality enhancement. Moving on to my last part, process strategy and layout decision. In terms of process strategy, we are considering lean manufacturing principles, value stream mapping and continuous improvement, and also resource optimization and cost effectiveness. For the equipment, we ought to use specialized machinery and tools, building robots, CNC machining centers, automated assembly lines, and also advanced testing equipment for performance verification. For the technology, we want to use advanced CAD, CAM software, 3D printing for lightweight and also strong components, and IoT sensors for real-time monitoring. For the layout decision, it is decided to choose optimization of workflow efficiency, minimization of material handling, and also ergonomic workstation design. Last one, layout design consideration, efficient space utilization, workflow optimization, flexibility for feature changes, and smooth material flow and communication, ergonomic design for employee well-being. So that will be all from my part. Thank you for the time, and I pass to the next presenter. Thank you.
Good day, sir. My name is Mohammad Hazik bin Muhammad Hassan. We'll continue with our human resource strategy. To accelerate the aerotrain repairs, our human resource strategy will focus on building a team that is both competent and efficient. First, we will recruit a core team of experienced engineers and technicians familiar with aerotrain system, supplemented by local talent for support tasks. Next, to ensure efficient and effective repair of the aerotrain, a meticulous labor plan will be established. The first element is personnel breakdown. A detailed breakdown of required personnel will be established, including engineers, technicians, electricians, welders, and safety specialists. Then, we will consider subcontracting for specialized tasks if needed. Next, to maximize the work efficiency, a well-defined work schedule will be established, and this schedule will incorporate 3 key components. The primary component will be a multi-shift system. A shift-based schedule will be implemented to maximize work hours while minimizing disruption. Secondly, overtime will be offered strategically to accelerate critical tasks.
Finally, the work schedule may also incorporate weekend-intensive shifts. This approach will designate weekends for concentrated work efforts, focusing on completing critical repair tasks and essential maintenance. Next, to ensure clear expectation and a safe working environment, a structured system for job classification and work rules will be implemented. First, clear job description will be outlined for each position, defining roles, responsibility, and qualification. Second, established safety protocols and work rules will be strictly enforced throughout the project. To achieve optimal repair efficiency, a comprehensive review of the work method analysis will be undertaken. The first area of focus is existing maintenance procedure will be reviewed and optimized for efficiency. The second area of focus is we will implement new technologies and best practice to improve the repair speed and quality. Next is the planning process of our project. To ensure a smooth and efficient repair process, the schedule will be a roadmap for the entire project, outlining key milestones, timelines for each task, and dependencies between various activities. Here's a breakdown of the planning process. Work breakdown structure, ground chart development, resource allocation, and risk management plan. To determine the optimal repair approach, the aerotrain system's capacity needs will be assessed. First, we will assess the current spare part inventory and identify any critical component requiring procurement. For critical component identification, through inspection and diagnostic, any critical component that are essential for restoring a minimum level of functionality to the aerotrain system will be identified. Third is lead time integration. This will involve thorough research to establish the lead times for any critical component that necessitates procurement. Next, demand option. The first element here is passenger throughput data analysis. Through a meticulous analysis of this data, we can determine the minimum aerotrain capacity required to effectively meet passengers' needs during the initial operational phase following the repairs. And then, the project will prioritize repairs to ensure a functional system with sufficient capacity for initial operation. Next, material requirement plan. For the first one is material and equipment list. A comprehensive list of material, equipment, and tools necessary for repairs will be established. Cost estimates will be prepared for all resources required. Last but not least for me is to review the scheduling. The project schedule will be continuously monitored and adjusted as needed to account for unforeseen circumstances. And regular progress reports will be communicated to MAHB.
Hello, my name is Tosimo Nganu and I will continue to the supply chain. Supply chain is a global network of organizations and activities that supply a firm with goods and services. The figure shows the example of supply chain. Members of the supply chain collaborate to achieve high levels of customer satisfaction, efficiency, and competitive advantage. For supply chain management, there are six sourcing strategies, which are many supplier, few supplier, joint venture, Keiretsu networks, virtual companies, and the last one is vertical integration. Next is shipping system. There are six types of shipping system, which are trucking, railroad, air freight, waterways, pipelines, and multimodal. From the six types of shipping strategy, there are three shipping strategy for KLIA Aerotrain, which are the first one is multimodal shipping, which is about cost reduction and time efficiency. The second one is waterways, uh, which is about long-term cost and effective supply, and the last one is air freight, which is about immediate delivery and flexibility. Mm-mm. Next is the maintenance and reliability. Maintenance is all about activities involved in keeping a system equipment in working order. It includes inspection, cleaning, lubrication, adjustment, and necessary replacement. And while reliability is the probability that a machine will function properly for a specific time, the objective of maintenance and reliability is to maintain the capability of the system. Okay, next is the impact of maintenance. The first one is maintenance cost. It is about the traditional view attempt to balance preventive and breakdown maintenance costs. And the second one is total productive maintenance TPM. It is about designing machines that are reliable, easy to operate, and easy to maintain. TPM also em- emphasizing total cost of ownership when purchasing machine so that service and maintenance are included in the cost. Okay, now is the maintenance strategies. There are three maintenance strategies, which is the first one is breakdown maintenance, which are no prior work required and high disruption risk. The second one is preventive maintenance, which are schedule work, high level costs and avoid breakdowns. And the last one is predictive maintenance, which is it is detect impending failure and it is high detection costs. As we can see from the slide, this is the five equation which is related to the reliability. The first equation we can find the reliability. The second equation is we can find the product failure rate. After we find the product failure rate, which is FR, we can find the mean time between failure, which is the equation is MTBF equal to 1 over failure rate. I think that's all from me. Thank you.
Let's move on. So, in any project, the application of management principles is crucial for effective planning, execution, and control. Clear objectives, scope definition, and a detailed work breakdown structure ensure optimal resource management and organization. Project scheduling determines dependencies, roles, and costs, while monitoring tools enable informed decision making. Quality management, resource optimization, and effective people management further enhance project efficiency. Supply chain management and risk mitigation strategies ensure smooth operations, while maintenance and reliability strategies drive equipment performance. Successful implementation yield cost savings, improve quality and timely delivery, satisfying stakeholders and providing a competitive edge. To ensure success, effective training, robust monitoring systems, and a culture of continuous improvement are essential. Collaboration with experts are regular strategies updates keep projects aligned with industry trends. With these strategies in place, projects thrive fostering growth and competitiveness. That's all from our group. Thank you.